Students, कुछ बात start करेंगे about another type of codes which are called as cyclic codes. Students, in the case of cyclic codes, we have a linear block code but with an additional property. Students, this additional property is that if the code word is rotated, if we shift some bit, one bit, for example, in this particular case, in a cyclic manner, then we get a code word which is again a valid code word. So the rotation of a code word in a particular direction, it results into another valid code word. Students, in this slide, what you can see is that we have got 1011 0000 as our code. Students, in this case, this cyclic code is a code word, and what we are doing is we are cyclically left shifting this code. So we are essentially shifting this one out here, and we see that this particular resulting code, which is 011001, is also a code word. So this particular case, we have got a proof that we are using a code which can fall under the category of a cyclic code. Students, the cyclic codes are of many different types. The most common one that are going to be used in the local area network and the wide area network context the most is a cyclic redundancy check, or the CRC. Students, CRC, we will encounter this particular error detection code the most. So let's go in and let's try to study this further. Students, as you can see on the slide, we have got a CRC code with the value of K as 4 and the value of N in this case is 7. Students, what we are doing is, in this particular case, we have got a data word. Let's suppose this first one out here of 4 0 bits, and all that we are doing is we are appending some more bits to it, and in this particular case, the amount of bits that we are going to append is calculated by n minus k, which in this case is 3. So we just add 3 bits to the end of this data word and we send this over. अब स्टूडेंट्स, ये देखने के लिए कि किस तरह से हम लोग इन डेटा बिट्स को जो कि हमने अपेंड किए हैं कैसे कैलकुलेट करेंगे, we need to look at the CRC encoding and decoding process. Students, on the left hand side you have the encoder, and all that we are doing in this case is we have a data word which is 4 bits. Once again, our k is equal to 4, and the code word in this case has n bits. So this is k is 4, your ultimate code word that we are going to be sending, it's got 7 bits. So n is equal to 7 in this particular case. Students, जैसा कि मैंने आपको बताया था कि data word is augmented by adding n minus k or 3 zeros to the right hand side of the word. Students, this n bit result is fed into the generator. ये 3 zeros हमने आपके code word में add कर दिए. This is all of these, the 4 data words and the 3 zeros are then fed into this particular generator. Students, in this case, this generator will use a divisor, modulo 2 division यहाँ पे होगी, arithmetic, and this will use a divisor which has got a size of n minus k plus 1. In this case, this size is going to be 4. Students, whatever the result is, we will discard the quotient and we will take the remainder, and this remainder will be added, the 3-bit remainder will be added to our data word, and this will make our code word which we are going to be sending over to the receiving side. Now students, on the decoding side, we receive the code word and we are assuming that this code word is going to be corrupted on the way to the receiver. So students, what we're going to do is a copy of all these n bits is then fed into a checker on the receiving end. Students, this checker is nothing but a replica of the generator that we used at the sending end. And students, as was the case with the linear block code, you know that this is a linear block code. So this creates a syndrome. The result that comes out by the checker is a syndrome of n minus k bits. As you can see, we have got 3 bits out here, which is n minus k bits. Students, this is fed into the decision logic. If the syndrome bits are all 0, if the S2, S1 and S0, they are all zeros, we will accept the data word and it's interpreted as having no error, otherwise the 4 bits are discarded.